behalf of Space Education and Research Foundation and on my personal behalf, it is my great pleasure to welcome Mr. Rakesh P. Rao and all the participants of this multidisciplinary webinar, the special webinar. And this webinar is special because today in India, this day, 25th September, is celebrated as Teachers' Day. And this particular series that we are having as 4 talks are in honor of that, the Teachers' Day. And today's topic is very, very exciting. It is Antarctica, the journey south, a very, very highly challenging research work and the expedition that many Indians and so also many other countries, the scientists and specialists of other countries also are taking part. A very challenging research work that go on around Antarctica. So that is what we are going to hear from Mr. Rakesh Rao today. And before I hand over this mic to Mr. Rao, I would introduce him to you. Mr. Rakesh Rao is a science enthusiast and he specializes in making scientific documentaries. He is an excellent photographer and filmmaker. He has been involved in many projects of Antarctica, astronomy centers in India. The latest work that he is involved in is making a documentary film on Himalayan glaciers. That also is equally challenging work that he is doing. He has spent over 14 months over a span of 3 years in the icy continent of Antarctic to film the construction of 3rd Indian scientific station called Bharti at Larsman Hill. As a part of 10th Indian Southern Ocean expedition, he was involved in documenting the scientific activity undertaken in the Indian sector of the Southern Oceans. He is currently involved in developing a documentary series on astronomy research in India. The project is called Astro Project. Apart from the documentation work, he is also very actively involved in several astronomy and science outreach activities across the country. He has worked on the NASA Spaceward Bound India expedition to high altitude regions in Ladakh, Jammu and Kashmir. So he has been a very excellent worker ever since he started this work. And with these few words, I now invite Mr. Rakesh P. Rao to share some of the challenges.
Thanks a lot, Professor Watt, for those kind words of introduction. And let me share my experiences to this amazing continent called Antarctica for the next half an hour to 45 minutes or so. Before I start, I should say good morning, good afternoon, good evening to people who have logged in from all across the world. I precisely don't know from where you all have come, so that's why all the wishes to you all. So Antarctica, when I talk about Antarctica, I'll be talking about it much more in detail over the next half an hour, 45 minutes. But before I even start going out there, let me just briefly tell you what I do. I consider myself to having, the world's coolest job. I say this coolest because, of course, I get to travel to some of the most extreme places, the most bizarre places, and at the same time, most challenging places. But today, in today's connotation, I'm going to say coolest because it is the coldest places. My last 4 to 5 expeditions have actually been to places which the temperature ranges from -30, -40 to higher altitudes in the Himalayas, which at around 17,000 feet, 18,000 feet, and things of that sort. So what I do particularly is that I document our researchers who are on field carrying out some of the amazing research, and at the same time, contributing the understanding of these places towards the world. So my job is to document them and come up with documentary films, which are much easier to understand for common public and things of that sort. So that's why I consider it to be the world's coolest job. And as a part of this job, I was very fortunate to be part of 3 Antarctic expeditions, the 30th, 31st, and the 32nd. So it was a back-to-back expeditions, and I could spend close to around 14 months over a span of 3 years doing 2 things particularly. One is documenting the science research, and second thing was even more cooler because I was involved in documenting the construction of the third Indian research station called Bharti. So right from the time of when it was in concept stages, all the way to the final bolt was put into place to the conceptualization stage. So it took us almost 3 summers, 3 austral summers to build a station, and was very fortunate to see and be part of the history in documenting the entire station construction. So over the next 45 minutes, what I will do is I'll give you an overview of what Antarctica is, why scientists love going to Antarctica, what challenges do they face, and I'll also give you a brief about the Indian Antarctic program, just in case if you all plan to actually put up a proposal and be a part of the Indian Antarctic expedition, and also share my experiences of this amazing continent. So I wish I could literally take you all to Antarctica, but since it's a virtual presentation and not possible for me to do that, let me virtually teleport you all to Antarctica over the next 40 to 45 minutes. So if you all have questions or something, you can keep putting it up in the chat. I'll see if I can answer it during the presentation. If not, then I will do it at the end of the presentation. So fine, let's then tie your seatbelts. Let's actually go on a journey. So I end up putting the slide because I'm not sure what the background is and what is your age group is and things of that sort. Because we go to schools right from the smaller kids to all the way to the college section to do presentations about Antarctica. And when we go to the smaller kids and we tell them about Antarctica, they are a bit confused, whether it's in the north or in the south. So I just thought I'll just put this at the start. I know it's a very stupid slide to put because everybody knows Antarctica is at the bottom of the earth. It's sitting there quietly, peacefully at the bottom. It's not interfering, and we are not interfering with it. But then it's really sad to say that whatever we do here directly affects Antarctica. And once the effects are in Antarctica, Antarctica will soon start affecting all of us. How? I'll tell you all in short while from now. But before I even talk about the challenges, the features, the science, and the Indian expedition, it's quite important for us to actually understand a bit of history of Antarctic exploration. I mean, just like space exploration, if you are interested to read, Antarctic exploration is nothing very small. I mean, it's one of the most exciting and the most interesting exploration ever taken by mankind. Sometimes, I would rather say it's much more easier to go to space than actually be in Antarctica. Or let me rephrase it in a very different way. The second best thing that anybody can do apart from going to space is going to Antarctica. And if you'll get a chance, I think y'all should actually think of doing an expedition there. So how did the entire exploration, Antarctic exploration, actually start? I mean, so let me take y'all way back during the time of Greeks. So the Greeks actually thought, like, they knew about the Arctic. So they thought that there has to be a land in the opposite direction that counterbalances the snow and the Arctic in the north. So that's why they called it as Antarctitus, which actually meant as opposite of Arctic. At the same time, there was a different notion of people who called it as Terra Australis Incognita, which actually meant as unknown land of the south. This was, it was, nobody had discovered it, nobody had seen it, nobody had even knew the presence of it, but they just felt there's an hypothetical land that has to be there just to counteract the North Pole or the Arctic. So that's why we had the Antarctic, and that's why the Antarctica gets its name. It took almost 17 centuries later when this particular man, Captain James Cook, decided to actually go on an expedition to discover the southernmost land called Antarctica. Limited by the technology of that time and the kind of ship that he had, he managed to cross the Arctic Circle. And when he reached Arctic Circle, he ended up seeing a lot of ice pieces and icebergs and fast ice, and his ship could not navigate through them. But when he saw these icebergs, he could actually also see remnants of dust and rocks all across the iceberg. So he could conclude easily that there has to be some land down south, still further away. And he also makes a very interesting statement. He says that I make bold to declare that the world will derive no benefit out of this land. I mean, 17th century, had it been today, we know how important Antarctica is. So it was in 17th century when he gave a presence that there is something down south, but he could not explore it because limited by the technology of that time and the ship that he had and things of that sort. But he reported some presence of Antarctica down south. It is claimed that in 1820, a Russian Navy officer by the name Fabian Belenchon, that he actually spotted Antarctica and actually landed over there. Now, this is a claim. There are disputes to this, and there are claims that this was a time when you had, post very close to all the wars that was happening between USSR and USA and things of that sort. So nobody wanted to claim. It was just similar to the man landing on the moon. Americans did it, Russians thought it's fake, and things of that sort. So there was a claim that he landed over there, but US people had another claim that there was a person from US called Charles Wickles who apparently landed there. But again, this is a claim, so I'm just putting it out there. But main exploration of the Antarctic started when it was a race to South Pole. And I need to mention these 2-3 gentlemen because these were the pioneer explorers of that time. I mean, what they went through is beyond doubt the craziest expeditions or the craziest exploration any sailor or any mankind has ever done. So it was this person by the name Roald Amundsen, a Norwegian explorer. He set out to reach the South Pole. So he reached the Ross Sea in Antarctica and decided, and they were supposed to walk all the way to South Pole. That was almost 1,000 kilometers away from Ross Ice Shelf. So on October 18th, 1911, he, along with 5 of his team members and 52 sledge dogs, set out sail to reach the South Pole. He managed to do so on the 14th of December, and he became the first person to actually reach the South Pole. And when he reached the South Pole, he pitched up a tent and planted a flag. And in the tent, he left a letter saying that, hey, Amundsen was here. We reached here first. So he reached and he came back to the ship and he sailed all the way to Hobart in Australia. And from where he sent a telegram stating that he has reached the South Pole and he has conquered by planting a flag over there. At the same time, there was another British naval officer who knew about Amundsen's exploration towards the South Pole, but at the same time, even he left to do the same thing, to be the first person to plant a flag at the South Pole. So he left again with a 5-member team on the 1st of November 1911, almost a month later from Amundsen, and he finally reached to the South Pole on 17th of January 1912, almost 33 days later than Amundsen. But unfortunately, when he reached there, all that he could see was the tent and the flag and the letter which said that Amundsen was here. And he was very much disappointed and was dejected that he was not the first person. And although they sat there, they took photographs and they planted their flag also. And on the way back, they were stuck with one of the worst possible blizzards of that time. And that led to deprivation of their food and led to exhaustion, and the bitter cold ended up killing all the five-member team. So the South Pole race was going crazier at that time. We had Amundsen reaching there, Scott reaching but could not reach back. And at the same time, there was another person called Ernest Shackleton. His story is even more amazing because he did multiple attempts to reach South Pole, but unfortunately, most of them failed. But what is amazing about this particular expedition of Ernest Shackleton is his leadership qualities. And I urge everyone to actually read more about him. Let me just brief you all about his expedition. So he was part of the Scott expedition way back in 1903 when he could not reach Antarctica but had to be sent back home because he had some health issues. So having got some experience, he decided to have his own expedition, and that's when he came up with this Nimrod expedition. And he reached Antarctica and walked all the way towards the South Pole, reaching only far behind of 97 miles. When he was just falling short of 97 miles, they felt that they could not take it anymore because they had no food and they were exhausted. So at that point of time, they just planted the British flag there, took a photograph, and they came back thinking that he will do it all over again down the line. So with that bit of advantage and knowledge about reaching almost 97 miles to the South Pole, he decided to come up with another expedition called Endurance Expedition. But at the same time, he even got to know that Amundsen and Scott had already planted the flags on the South Pole. So there was no point of him actually going to the South Pole and doing that. But the adventure instinct in him said that, fine, if somebody has already conquered the South Pole, let me be the first person to actually navigate from one end of Antarctica all the way to the other via the South Pole. So he set out on his endurance expedition, and everybody needs to read the endurance expedition. It's so amazing understanding how the expedition went and how it failed and things like that. So what happened was in 1st August 1914, he set out Shackleton with his endurance. They left to Antarctica. And unfortunately, as they reached closer to Antarctic coast, the ship got trapped in the fast ice. So they managed to, dig the ice out, but every day there was more fast ice that were getting trapped. I mean, trapped. The ship was getting trapped every day. So they survived on the ship for almost 11 months, and ice started crushing the ship, and on eventually the ship actually got crushed and got destroyed, leaving 28 men along with Shackleton and 3 ships on the fast ice. So these people, they just drifted on the fast ice along with those ships, and they reached a small island close to the Antarctic coast called Elephant Island. And on reaching there, Shackleton realized that there's no point surviving on this island because there was no food or no other animals that they could hunt and survive for a long time. So he decided to take it upon himself. He, along with 5 other men, took a boat and sailed through one of the roughest possible seas along the Drake Passage to reach South Georgia Island, where he could get the rescue plan done with all the other people. So he reached South Georgia Island, and what's the most amazing quality about Shackleton is that he did not leave any man behind. He came back almost a year and a half, a year. It took almost a year for them, the team member, to get rescued. But all 28 members were rescued finally from Antarctica. So this particular expedition is also termed as a successful failure because they could not conquer what they wanted to do, but it was successful rescue expedition. So these are some of the pioneer people which I wanted to share with you all. And I would really urge everyone to actually read much more about them and feel what they went to. There is a beautiful book called Scott Diaries. So you can even think, and he used to maintain a diary of telling every day's day-to-day event what was happening. So you need to read that also if you're interested. So Antarctica, I mean, if it's there sitting down right at the bottom of the earth, minding its own business to say, but people think it is, very small and it's there down and things like that. But it is not the case. It's the fifth largest continent, and it is almost 14 million square kilometers in area. It looks small, but it is huge because it's at the poles. It's extremely big. Now, how big it is? Just to give a rough idea, you have the area of India and area of China. You can take both of that area and dump it into Antarctica, and you'll still have some area left where you can fit in some islands of Indonesia and Mauritius and Maldives. So it is huge. It's extremely huge continent. At the same time, what's interesting about Antarctica is that during the winters, the Antarctic continent area actually doubles. It's not the land continent land area that doubles. It's basically the ice or the sea which is surrounding the Antarctic region freezes because the temperatures go down to minus 30, 40 at times, and it freezes and it freezes and it expands. It expands to almost double the size. So there's a small graph. There's a graph out here. If you can actually take a look at it, during January and February, you have the peak summers. So all that sea ice that is frozen during the winters melts, and then you have this image on the right that shows you the Antarctic continent and the small ice pieces that is there over here in the Weddell Sea. But during winters, the water or the ocean, the southern ocean, part of the southern ocean, which is surrounding the Antarctic region, actually freezes and doubles up almost close to 19 million square kilometers. So you have 19 million square kilometers of sea ice plus 14 million square kilometers of the Antarctic land, which actually expands. So that's why it ends up becoming one of the biggest continent during the winters. But this is a seasonal variation. It is not always, and the variation changes from summer to winter. It is one of the coldest places on this planet Earth. It is so cold that there is a station in Antarctica called Vostok. That's a Russian station. It's right there, here, close to the center of Antarctica. The temperatures were recorded of minus 89.2 degrees Celsius. I mean, it's insanely cold. I mean, how cold, if you want to imagine, is that your reefers and your refrigerators at home, the ice, when it freezes, temperatures can be that particular box. The temperatures are around minus 18 to minus 20 at max. And this is almost 4 times that temperature. And at minus 89.2 degrees Celsius, that was the least that was recorded. There are people, there are scientists, there are researchers who are there in that station during those extreme cold temperatures, who are understanding and doing science out there. Just to give you a small graph of this, so at the South Pole, the temperatures can, during the peak summers, can range anywhere from minus 20 to minus 30, and during winters it can even reach down to minus 65. Whereas McMurdo Station, which is at the coast, temperatures can vary anywhere between 0 during summers. Of course, there are times when this is an average temperature. So there are times when temperatures have even reached to plus 5 degrees in Antarctica. And during winters, it can go all the way to even minus 30, minus 35. And this is at the coastal Antarctic. Whereas Vostok Station, the average summer temperature itself is around minus 30, 35 degrees. Winters, it can touch anywhere to 65 and more. And this is the same place where the lowest temperature was recorded on one particular day of minus 89.2. Antarctica is also the driest continent. Although it is quite strange, Antarctica being surrounded with ice and from all across, and ice on the land itself, it's one of the driest continent. I mean, there are places in Antarctica where there has been no precipitation in the form of snow or rain for almost 2 million years. It is absolutely dry. There is even very minimal water vapor or the humidity content out there. This places, now where is this dry valleys? is there's another photograph on the right, satellite image that shows you this with all the ice surrounding it, and these are the valleys of the dry valleys, and this is towards the south of Antarctic, very close to McMurdo Station. This place is of late become very important for astrobiologists because these are the places where the researchers come and try and find organisms like bacteria, viruses, or fungi kind of organisms, because this particular region gives us quite similar analogous condition to what it is to finding life on Mars, because Mars has the similar condition, like it is dry, it is extremely cold, and so finding life here can even lead us to understand what it would be and how or where to search for life on Mars. So astrobiologists are very curious. It's just again not Mars. Even the moons of Jupiter and Saturn are potential places for life hubs. So these organisms are called as extremophiles, which scientists come every year to these dry valleys and try and understand the kind of formation and how these life can survive in these extreme cold places. Antarctica by far is the highest continent also, because if you take the average mean height of all the continents, uh, Antarctica is somewhere close to almost 2,500 meters high. And there are places in Antarctica, if you like the Dome A, there's a place in Antarctica. If you drill from Dome A straight downwards, you'll actually go through an ice of almost 4 kilometers. So from the mean sea level. So there's almost 4 kilometers of ice on Antarctica. Antarctica is more like a dome shape. So if you go to the height of the dome and drill, you get almost 4 kilometers vertical, down, the 4 kilometers of ice below the surface. So averagely, it is the highest continent. It is also the windiest continent. By far, it's the most windiest at times. Fence station, Dumont d'Urville. It's a fence station, and the highest wind speed that was recorded there was almost 327 kilometers per hour, almost 200 miles. To give you a rough idea of what 200 miles is, if you take the Indian tropical cyclone, there are different categories of cyclone. The worst possible cyclone, of the category 5 cyclone, has a wind speed of 155 miles. That's almost 300 kilometers, roughly close to 300 kilometers wind speed. And the recorded wind speed at the fence station is almost 327 kilometers per hour. To give you a comparison, one of the worst cyclones that struck Indian coast in 2008, Cyclone Nargis, was 215 kilometers, and people from US would know that Hurricane Katrina, when it hit the US coast, the wind speed was almost 280 kilometers per hour. So it was much more higher than any of these things. But it doesn't mean that the entire Antarctic continent, the winds are so high. There are times when you have such high winds. The main reason for high winds are basically because the dome shape. You have something called as katabatic winds. You have winds coming from the dome flowing towards the coast, and because the gravity and the pressure system, the winds are actually pulled towards the pressure systems down towards the coast. So the winds are extremely high. That's why it's the windiest. It's by far the remotest and the emptiest continent at the same time. It is so remote that the closest civilization is like if you are in the peninsular region, that is this region. Closest is Chile, Argentina, which is almost 1,000 kilometers away. For us from India, we have a station called Maitri. That's here. The closest station, closest civilization is Cape Town, South Africa, or Cape of Good Hope. That is almost 4,500 kilometers away. It's so bizarre and frozen and hostile and remote that there are no permanent inhabitants of Antarctica. I mean, you will never find native Antarcticans in Antarctica. Whom do you find? You find scientists who are there over, all across the Antarctic continent. They have established almost close to 70 research stations spread all across Antarctica and in the center and different other places. And during summers, that's when the activity is there, and you have the daylight and a lot of other climatological changes happening. You have more number of scientists coming down to Antarctica. Almost 4,000 scientists on a given in a given year, you'll find during summers in Antarctica. And during winters, the size reduced down to almost 1,200, of which you'll find very few scientists, but majority will be logistics personnel, which includes engineers and carpenters and other people who can maintain the station throughout the year, because you can't leave a station empty during the winters. Some of the features, I would like to talk about some of the features in Antarctica. The entire Antarctica is covered with almost 98% of ice. The entire Antarctic continent. Go anywhere, it's almost ice literally everywhere. Almost 98% of Antarctic continent is covered in ice. That particular ice is like 90% of the entire world ice. So where is the remaining 10%? Well, it is in the Arctic and other cryospheric regions like the Himalayas, the Alps, and the Andes, and other mountainous regions where there is ice in the form of glaciers which are stored. 70% of world's fresh water is in Antarctica in the form of frozen ice. And it is so strange that when we were there, even there were times when we ourselves had problems getting water because we could not, melt the snow, and it was taking time. So there's water everywhere in the form of snow and ice, but when you want water to drink, it becomes very difficult. But having said that, if you remember the previous height of the mountain height of Antarctica, there's almost 2.5 kilometers of ice thickness. Had given the fact, I mean, there's so much of ice that the quantity is almost close to 27 million cubic kilometers. And if by chance, if tomorrow, if this particular ice melts, I mean, that is how Antarctica would look. That's a bed map 2 image of the terrain features of Antarctica without the ice. And if all that ice would melt, the sea level would rise by almost 58 meters. I mean, just imagine, even if the sea level tomorrow rises by a meter or meter and a half, then almost all the coastal cities, like say New York, Bangladesh, Bombay, or for that matter, even the place where I come from, where the presentation is currently, I come from Goa. I would rather be doing this presentation with almost, inside the water than being on the surface, because I stay very close to the coast. And entire coast would have been wiped off with almost a meter or a meter and a half sea level rise. So just imagine a 58-meter sea level rise would actually would change the entire world map as we see. And that is one of the reasons why Antarctica is very, very important for us to monitor and understand the climate change impact in Antarctica. So other features, as I showed you, this was all about Antarctic ice sheet. From here, we go on to ice shelf. Ice shelf is nothing but it's more of an extension of ice sheet, but on water. So it is basically the sea ice, which has been frozen for thousands and thousands of years and has become an extension of the ice sheet. So, for instance, if you go on an ice sheet and drill, say 100 or 200 meters, and in some places 4 kilometers, you will hit the land surface. Whereas if you drill on an ice shelf, there are thickness of ice shelf which can range from 15 meters to 600 meters. And if you drill through it, you'll reach to a place when it's all water below it. So that's the difference between ice sheet and ice shelf. And there are several ice shelves which are around Antarctica and are currently being monitored extensively, because a simple ice shelf like the Ross ice shelf, if it melts, that's when I was talking about the 2-meter level rise. Moving away from ice shelf, you have the fast ice and the iceberg. The first slide that I showed you about Antarctic size expanding, it is because of these fast ices. So these are nothing but these are sea water which gets frozen during winter, and during summers they melt back and form water. So these expand and melt depending on the season and variation of time. The icebergs are again a different part. They sometimes break from those glaciers. The entire Antarctica is actually a big glacier. Okay, it's the entire Antarctic continent itself is a glacier, so it has extensions and things where it empties itself into different places. And when it does, it actually breaks off this particular iceberg, and icebergs are formed. Even the shelf ice, when it breaks, it's there. So these are some of the other photographs that I took during my expedition of the icebergs. So of the 98% that is covered in ice, there are some other regions which are ice-free, almost like 2%, 1% of ice-free is mountainous region. And other places are, they have plains, and there are some places from where the mountain actually rises up from the ice sheet and forms something called as a nunatak. So these are just like, protruding mountains coming up from the ice surface, and they're beautiful looking mountains. And this is one of the mountains. And if you see here, there are a lot of small pieces that look like rocks, but they are not rocks, but they are like small containers. And here, right on the edge of the mountain, we have the Prince Elizabeth Station, which belongs to a Belgium station, and right at the corner of the Nunatak. So you can actually compare, and that's a big station. You can actually compare the size of the Nunatak to that particular station. There are other big mountains also in Antarctica, not as big as the Mount Everest or the Himalayas, but then yes, there are pretty big. This is a Wilson Massif, which is almost 4,800 meters from the mean sea level. And it is strange to also note that we have an active volcano in Antarctica. It's called Mount Erebus, which is again close to the McMurdo station. We have a range of Antarctic mountain that runs all the way from the south to the northwest. It's called the Trans-Antarctic Mountain Range. So if you see here, it runs all the way from the south all the way to the northwest, and it stretches to almost 3,500 kilometers. I mean, it's not the biggest mountain chain, but it is one of the biggest, because the biggest is the Andes, which runs from the north to south of Southern American continent. Our Himalayas, for that matter, is just 2,800 kilometers. So this is 3,005 kilometers of mountain range, and it ranges all the way across. Just to sum up all the features that I just talked about, this is a beautiful illustration that is there. So you have the Antarctic ice sheet, which sits on the land, and then the extension of it, of the frozen sea ice plus the extension, extends on top of the water, is called the floating ice shelf. And still further down, you'll have the fast ice, which melts and refreezes depending on the season. And these ice shelves, when they break, they form icebergs. So these are some of the features that Antarctica possesses when you get it. So the question is, who owns Antarctica? I mean, so it's fine. It's a very big continent there, and it's sitting there, and so somebody has to own it. But the best part is, nobody owns it. Way back in 1912, around, many countries actually ended up, planting their flags and started showing that there are territorial claims. They started claiming places of Antarctica. And it was quite interesting that Germany, during the Nazis' time, also had set up a claim in Antarctica, that particular region. And why was it important to claim Antarctica? Because Antarctica has a huge deposits of coal, uranium, and other minerals that are there. Of course, it holds 70% of the world's fresh water. And people thought it's a barren land. It's a good place to test all nuclear warfare. And that was a time when, you had the wars happening and things of that sort. So it was the initiative taken by the US President, then US President Ebenheiser, who thought, it's important for us to conserve this particular, the last piece of land for mankind. And he came up, and he, along with several other dignitaries, they came up with this idea of forming a treaty. And originally there were 12 people. He actually initiated something called as IGY, International Geophysical Year, during which he sought collaborations of all countries and scientists, forgetting all the war, to actually do science and come together. And as a part of that IGY, they were scientists in Antarctica trying to understand the geology of Antarctica, climate change, and its impact. And once when the report went back, they decided that Antarctica should be kept idle and nobody should be able to put territorial claim on it. And that is when they came up with this treaty, And on the 1st of December 1959, the treaty was formed, and 23rd June 1961, it was enforced. And originally, there were just 12 signatories. Many countries were not sure. And today, as on 2018, there are almost 53 nations which are part of the treaty. And India initially was just as an observer, but now has a consultative status because we do contribute a good amount of force to Antarctic science. So, what does the treaty actually say? In short, it is a pretty long treaty, but in short, just to give the emphasis on the important points, the treaty says that Antarctica will not be used for military at all. There won't be any military presence or no military testings or anything of that sort. It will be only used for peace and science. You can go and do science and peace and nothing else. And the science that you do should be open. I mean, every international, there should be freedom of scientific collaboration. Now, tomorrow, if we have a station, Indian station there, and there are people in Australia and China, they can very well come and collaborate with the science being done, and we can also go and collaborate with the other countries. So that's one of the important regulations of the treaty, and it is very much into effect as of now. So, having said all this, let's come to the important point of why Antarctica is important to scientists. Antarctica per se can be arguably told that it's the most untouched, undisputed, undisturbed, remote, and extremely pristine environment that you can find anywhere on Earth. So for any scientist who want to do any baseline study to understand what is the climate today and probably few years down the line, or meteorological phenomena, or marine biology, how is the productivity of different animals out there, geology, astronomy, ecology, different areas, they can go and do it in Antarctica because they'll find everything. Even the air is so fresh. And there are places in Antarctica, like close to our own Bharti station, we do have several places and several ice-free areas and small hills. And when I was there, practically when I used to go on an exploration, I used to just walk out during some time whenever I'm free from work, just to visit some of these places. And arguably, I would have been the first person out there because there's been never any human population that has been there. So there were a lot of firsts that I could do in Antarctica. That's the reason it is undisturbed and nobody has been there. So that's why it's one of the best places to conduct any science in Antarctica. And what are the kind of science that happens in Antarctica is one thing is the climate change related studies, and it has many subdivisions. You have people studying meteorology, ozones, and upper atmosphere, geology, and many other things come from and part of climate change. But one very important thing that happens in Antarctica is the study done using ice cores. So what are ice cores? Ice cores are nothing but every year you have snow falling on Antarctic continent, and when the snow falls, it actually traps a lot of air around, and when the air gets trapped, and the next year there's another snow deposition, and it keeps happening for thousands and thousands and millions of years. Every year you keep having compression of this snow, and it forms thick ice. I mean, very strong ice, and it keeps forming. So when you drill through Antarctica and you drill a core, I mean, there are people who have gone up to like 2 kilometers of drilling into the ice. And when you pull that core out, you're actually getting the past. So here is an image of an ice core. This is a machine for coring, and this is an ice core. And when you see the ice core, you can actually see delineations of the color between white and a bit black and white. So these are the seasonal variations. During summers, you have more activity, more melting, and the winds are high. So you have dust and other particles that will come and settle with the snow. And during winters, it is dark, it is quiet, and there's less amount of winds, and there's no melting that happens. So you find them as layers as white. So what generally scientists end up doing is once when they find the score, they actually make thin sections of it, and like this particular thing. And if you see these bubbles, these are the air that is trapped in that particular layer of ice, which can be thousands of years back. So then they do something called as isotopic analysis. They melt that particular thing and escape the air, and that air they study isotopes of oxygen and few other atoms, And when they do the isotopic analysis, isotopes, I mean, are like thermometers. They can give you a lot of parameters. Like you can actually recreate the temperature profile or the history of what the temperature was in Antarctica some thousands of years back. And it's just not the temperature. It can tell you about carbon dioxide, the greenhouse gases, what has been the interference, whether there has been a volcanic eruption. You'll find a lot of ash around it and things of that sort. So ice cores are very, very, very important for recreating the past history that will tell us the current future and help us predict our current situation and help us predict the future. Another interesting contribution that came from Antarctica is the ozone hole. I'm sure everybody would have heard this term called ozone hole, which was over the Antarctic. And ozone is very important. It's a small layer up in the upper stratosphere, and O3 molecule basically, and it protects us from harmful radiations coming from the sun. And yeah, so when it does, and what was happening is that during 1970s, 80s, we started using CFCs, that is chlorofluorocarbon, in the form of in refrigerators or in air conditioners or even the deodorants and perfumes that we're using as propellant. So whenever these CFCs were getting escaped and heading towards the upper atmosphere, they were actually rupturing. I mean, they were the layers, the sun's rays were actually breaking over the chlorine, and the chlorine was actually getting attached or dissociating O3 molecule and destroying ozone. And the hole, when I say about hole per se, it is not a hole as in it's not a literal, I mean, that is not the area where the sun rays will directly come. It is just the concentration, I mean, difference in the thickness. Just to give you an analogy, if you stack two quarters or two coins on one top of each other, that is when you have the natural layer of ozone. And in ozone hole, you just have only one quarter. So there's a difference in the thickness. And that thickness is considered as a hole. So there is no literal representation of the word called hole. So you don't go through and through, the rays don't go through and through. It's still protecting. So because of this, a Madrid protocol was formed, and it was decided to have a ban on CFCs. And this ozone hole and the implication can tell us, how vulnerable our planet is and how human activity can actually destroy region, and that is what we have been doing, and that's the saddest part, kind of a thing. Moving on, there are a lot of meteorological studies. People are monitoring by putting weather balloons and AWS and a lot of upper atmosphere, lower atmospheric studies, which are very important to understand. Astronomy community from all across the world are pretty much excited to go to Antarctica. Of course, it does provide a lot of logistical issues and engineering issues because it's extremely cold. But it does provide you some of the best things. I mean, you have clear skies at times for, 3 months, 2 months, 3 months continuous. So if you're doing any transient phenomena, like you have any supernovae or cometary studies or whatever, you can do long-term monitoring from Antarctica. But apart from observational, there are people who have gone and set up, Antarctica is best place for doing sub-millimeter kind of studies because there is no water vapor. So generally in tropics, you have so much amount of water vapor, so the sub-millimeter range gets attenuated because of this particular water vapor content. But Antarctica being the driest, it's one of the best places to do sub-millimeter kind of observations. So this is a South Pole Observatory. It's the BICEP telescope doing sub-millimeter, the cosmic microwave background studies. And there's another observatory again in the South Pole called Ice Cube Neutrino Observatory. So they have drilled 2 kilometers into the ice in multiple places and have put a lot of sensors. So whenever you have any neutrino observations being done, it passes through this particular thing and you can kind of study neutrinos from there. Antarctica is one of the mecca for geologists if they are interested. And it's kind of interesting for us also in India for a very simple reason that millions of years back, the coast of Antarctica, where the new station is Bharti, was actually a part or attached to the east coast of India towards the Orissa and Andhra Pradesh coast. So there was a connection between India and Antarctica millions of years back. So when you had the plate tectonics happening and the drift happening, so we do end up finding similar geological features in the place where Bharti is and uh, the east coast of India is. Meteorite search, again, it's one of the best places to hunt for meteorites. The reason being that when you have meteors falling on say in the tropical regions like say India or anywhere, you have so much of exposed area, and whenever it falls on land, you also have constant. It's been disturbed by growth of plants or construction or different other phenomena, and also there's a lot of weathering that happens. You have rains coming and going and all those things. In Antarctica, whenever there's a meteorite that falls, uh, it gets attached and remains in the form of a very pristine form. So it remains there. And if you see this cartoon over here, it actually tells you, and when you have the glacial movement, it actually picks up all the meteorites and dumps at a particular place called moraines. That is where you end up finding crazy amount of meteorites. There are teams which come from US, Japan, and end up bagging almost close to 600 to 800 meteorites every expedition. And these meteorites can be from Mars or early time of the formation of the solar system. Geomagnetism, it is again one of the best place because you have the auroral activity that happens, and it's one of the beautiful phenomena. And I also could manage to actually take a photograph, not particularly a selfie, but I don't know what you'll call this because my back was formed to it, and with the beautiful auroras that happens there. So there are a lot of geomagnetism studies that happens there, and the flora and fauna are something one of the best parts. So there are no natural native inhabitants, but the population of Antarctica controlled by these two creatures, the penguins and the seals. So there are crazy amount of emperor seals all across, and of course there are 5-6 different native penguin species to Antarctica, and this is one of them. And if there are any enthusiasts who want to study about flora fauna, it's quite important if you can actually read about the penguin story of how the penguin, the mother lays the egg and the father actually takes care of the egg in the craziest winter, keeping the egg in its warm pouch just below its, above its leg, and where the temperatures outside can go to -30, -40. The egg inside the pouch is at almost +16 degrees, so it can hatch. And after 3 months, when the chick comes out, the father has almost lost almost half of its weight because he has not eaten for 3 months. It's just been there. And there are many emperor penguins which come together and hurdle around and take circles during blizzard. So you need to read that story. It's some of the most. And if you're not interested in reading about it, you can watch this beautiful documentary called The March of Emperor Penguins. Again, it gives you an amazing feel. There are no trees as such in Antarctica, so you won't find any coconut or mango tree or any other acacia or anything of that sort. But what you find is the fauna in the form of the flora in the form of these lichen species. There are a lot of algal mats, the lichens all across Antarctica, which again they are seasonal. They come out during summers, and during winters they are dormant. There are a lot of avian fauna that is there. This is one of the migratory birds called skua. It's again a well-adapted migratory bird. You need to actually understand how it's a predatory bird again. And this is a native bird. It migrates all the way from the north to south. The Arctic regions to Antarctic during summers, and then it heads back to Arctic when it's winters in Antarctica. Snow petrels, these are the native species to Antarctica, and I was very fortunate to actually to document entire life cycle of the snow petrel. So we had one of these petrels breeding, so it laid eggs, and eventually down the line there was a beautiful chick that was born to it. The marine ecosystem is a different plethora altogether. The water surrounding the Antarctic, the Southern Ocean, is a different topic. I mean, I can have five presentations just only on Southern Ocean uh, and the species that are there. These are some of the crazy, bizarre looking organisms which were fished out from almost 1,000 to 2,000 meters depth. And these are squids and the baby larvae squid, and some very bizarre looking, and most of them are bioluminescent because they are at a depth of almost 1,000 meters below. So there's no natural sunlight that passes through the water or the euphotic zone, whatever they call it. So after 1,000 meters of depth, there is no light, so they have to somehow attract the prey. So they're all bioluminescent. So all these species, if inside the water, if you could see them, they would be actually glowing with different light. This is a very important marine species. It's called the krill. Although it is very small, it can range from anywhere from 1 centimeter to a maximum of say 4 or 5 centimeters. And they're very important. They look pretty similar to our crustaceans that we end up eating. But these krills are very important for the biggest mammal that's there on the planet, the whales. The whales actually feed on tons and tons of krills every year. And with the current situation of climate change and things of that sort, they have seen some proportions of decrease in krill population, which end up affecting, the bigger on the top of the tree chain. So there's a lot of effects that are happening because of these. I'm just giving you an overview of what to expect in Antarctica. So because each and every topic would be like, another presentation altogether. So running out of time, so let me just quickly talk a bit about India in Antarctica. So India started way back in 1981 when the then Prime Minister Indira Gandhi flagged off the Indian expedition, and it was under the leadership of Dr. S.Z. Carson. So he, along with a team in this boat called Polar Circle, ended up reaching Antarctica in 1981, and by 1983 we ended up establishing our first station called Dakshin Gangotri. The station was not established on the Antarctic ice sheet, but it was on the Antarctic ice shelf. So it was a two-story structure when it was constructed in 1983, and by 1989-1990, every year the station started to sink because it had its own weight, and every year snow deposition kept on sinking. So the station had to be abandoned by 1989. Before that, the team members were actually entering the station through the second floor window. There were times when they had to enter blizzards and storms. So rather than entering from the door or the first floor window or the ground floor window, they were actually entering from the first floor, from the top of the thing. And this is a photograph a few years down the line when the station is almost sunk. And today, if you go to Antarctica, the station is almost like 100 meters below, and there's just a small rod which is planted on a plaque which says that Dakshin Gangotri. Yeah, and it has been designated as an historical site. It is given a number called HSM 44. It's a historical monument that existed. So by 1989, we understood the importance of doing research and got a brief idea about how logistics work and how engineering is needed and things like that. So that was more like a makeshift station for us to just establish and understand how it is to be in Antarctica so that we can gain our expertise. And by 89, we already had those expertise, and we ended up constructing Maitri station, almost 80 kilometers from Dakshin Gangotri in a place called Shimachar Oasis. Where exactly is Maitri, if I can just take you back. So if you are standing in Cape of Good Hope and you start swimming towards the south, you will actually come straight away to Maitri. And if you are in Kanyakumari coast and you start swimming and come straight away down, you will end up reaching the new station, Bharti. So Maitri was constructed on an ice-free area on a proper land and not on a sheet or of ice or shelf. So we had Maitri being constructed in 89, and until today it is still operational. Of course, it's become a bit old now, and there are proposals to build another station close to it. and use this for as a spare station, just in case. But in 2012, we understood the importance of doing research, and we had almost explored Maitri station and the research that was happening there. And it was then important for us to understand research happening from a different location. So that is when in 2010, the initiation happened, and we started building the Bharti station. It took us 3 austral summers to build it. And in 2012, the station was constructed. And the station is such a beautiful station. It just looks like, if anybody's a Star Wars fan, it looks quite similar to Enterprise Star Wars spaceship. And the station is so high tech that today, if we have the IP settings, we can actually control the station, the fuel, the lights, the telecom, and everything. The air vent, to you name it, you can actually control it from India or from anywhere in the world. Because there's something called as the station has called as building management system. So there are a lot of more than 5,000 sensors which are put all across the station, and that in real time that's been monitored back here in Goa in India. So there are 2 remote sensing antennas which have been put. These are the ones which actually help us, earth stations. There's a third one which has been recently installed. These are inside this dome shape, there is an antenna which provides us the communication and high-speed internet. And at the same time, it also it is used to dump the satellite data and then transfer it back to India. So you can do real-time monitoring, because in the poles you get more number of satellite passes, so you can dump in more amount of data. So entire activity is currently controlled by the National Center for Antarctic and Ocean Research, which is very much situated here in Goa. And so how does one go to Antarctica? Is that today, if you're selected, National Center for Antarctic and Ocean Research has a call for a proposal call for scientists and researchers to come and do the proposal. And once the proposals are accepted, it also doesn't mean that you can just pack your bags and leave to Antarctica, because Antarctica is totally a different terrain, and it's quite challenging. So you need to be trained for it. So we get our training. We of course have to undergo a very strenuous medical examination, because it is so remote that in case of medical emergencies, you cannot be evacuated. You have to be there and come at the time when you're designated to come. So that's why a medical examination is done. And once the doctors have given you a go, no go, and you're fit to go on that, you still don't get a permission to go to Antarctica, because you have to undertake a compulsory 10 days of pre-Antarctic training, and that happens in Oli. There is this Indo-Tibetan Border Police Force. They're the ones who train our soldiers in Siachen and other places. So we get a basic training of how it is to walk on snow, or how it is to, if you fall into a crevasse, how do you rescue yourself, basic rope training, and basic first aid, rescue operations and things of that sort. So it's a good thing to acclimatize and understand how it is. And once they give a certification that you're fit, you're perfect to go, then you end up going. So before the 25th expedition, the Antarctic expedition is to leave from Goa, and it is to take almost 40 to 45 days to reach Antarctica, and it is to be actually a waste of time of 45 days of science and scientists, engineers doing nothing. I mean, of course, just to monitor the oceans, but still, it's a wastage of 45 days of expedition time. So now what we do is we fly to Cape Town in South Africa, and from there we either take a voyage, depending on where you're going. If you're going to Bharti, you take the voyage, and if you're going to Maitri, you have a flight option as well. I'll just talk about that. So we have that happens. So the first 2 days of the voyage is pretty amazing. You sail beautifully into the the Atlantic Ocean and the Pacific Ocean, and then you touch the Indian Ocean and the Atlantic Ocean, and then you touch the Southern Ocean. And Southern Ocean is notoriously known as for its rough seas. I mean, sailors have given designations to it. They call it as the Rolling 40s and the Furious 50s. The first time when I went, I never understood the concept of what it is to be in a Rolling 40s or 50s. So it's extremely bizarre and extremely difficult. So the ship that was doing smooth sailing started actually taking the plunges. If you want to actually see how it is to be in rolling 40 or 50, you can just YouTube rolling 40s or 50s, and you'll get a link of understand how the ship actually goes through it. And the the seas are known to be notorious, and there are a lot of storms and small low pressure zones, and you can't avoid it. You have to go through it. So many of them end up having a lot of seasickness issues and getting stuck to their bed for almost 3 to 4 days. But once you touch close to the Antarctic coast after 60, 65 degrees south, you start seeing these beautiful pancake formations. These are actually melts of the fast ices. During the summers, they melt and they start forming these pancakes. They're called pancakes because they resemble the pancake. And then very soon you start seeing the icebergs. So all those people who were seasick suddenly start getting good amount of energy back, and they're out on the deck to watch these beautiful icebergs. And as you go closer and closer, you start seeing the small layers of sheets of Antarctic fast ice. And this is how the expedition ship looked. I mean, we're still using this particular ship. It's a Russian ship, so we charter it. It's called Ivan Papanin. It's an ice class ship. It's not an icebreaker. It can break. I mean, it can break up to 1 meter of ice. Again, people have this notion that icebreaker has a cutter in front or a hot metal rod in front, but that's not the case. So if you see a regular ship and an ice class or icebreaker ship, the only difference you'll find is the superstructure. Is this general ships have a superstructure which are behind, but an ice class or icebreaker ship will have a superstructure which are in front. So what the ship does is that it comes in a very fast speed and it actually goes and sits on the ice. It goes and rams on the ice. So because of the weight of it, the ice actually cracks, and that is how you end up making your way through it. So when we were going, we had to go a bit earlier for the construction activity. The ice was still thick, so we had to use another ship called Vladimir Ignatuk. It was an icebreaker ship, so it has a strengthened hull and it can break up to 3 meters of ice. The other option to reach to Antarctica is by this crazy flight journey. It's a military plane called IL-76. It's again operated by a Russian group called ALCI, and we fly from Cape Town. And this is a modified plane, modified military ship. So inside the plane, you will never find it like a regular aircraft or plane. There's no cosmetics or there's no beautiful structures or place where you keep your bags or anything of that sort. There are flags of all countries, but the moment you remove the flags and see what is there, you'll find all pipelines and all wires all across. The reason being that they want to reduce the load by these cosmetics thing and increase the cargo load so they can carry in more cargo. And it's a 6 hours of flight, 6 hours of flying around with the fuel pipeline that you can see around. So after 3 hours, the person in charge makes an announcement that it's time for you to start wearing your polar clothing. So we end up standing on the seats and wearing a polar clothing. And the moment you reach Antarctica, this particular flight ends up landing on a Novo air base. And from there, the Maitri station is around 14 kilometers. So you end up coming to Maitri station. And if you want to go from Maitri to Bharti, it's also not a ship route. You can also fly to Bharti in a very and the distance is almost 3,000 kilometers. I mean, it's much more the distance from Kanyakumari to say Ladakh. It's much of it. Okay. So I'll come to the questions later. So yeah, we have if you want to go to Bharti, you end up using the smaller plane called Bafla. It's a 14-seater plane with a lot of uncomfortables. You have luggages stacked all across, and whenever there's a bad system or a low pressure system and there is turbulence, you sometimes end up having luggages falling on you. But it's a beautiful experience altogether to be there. And this is what it is once you reach the Bharti area. This is called a Bharti promontory, and this is where the runway is. So there is no runway as such. I mean, there's no tarmac or there's no taxiing or anything of that sort. You just come and hard it and you land on ice. And they just make it smooth. So there are vehicles that will just flatten the surface of ice, and then the airplane comes and lands on the ice. And then we come to the Bharti station from here, which is almost some 3 kilometers away. And this is a beautiful small island, and it becomes an island only during peak summers. Rest of the year, this is all frozen fast ice. So you can actually walk from this island to this island on the sea ice. And it's only during peak summers that you have it empty. So this was the construction activity that started off there, and once the station was constructed, it looks beautiful as I just showed it to you. These were the construction of the two radon structures of the ISRO. ISRO has set up these facilities. NRSC is monitoring it, and this is how the station looks. This is again during peak summers when we had 1-2 days of good weather. Now, when I say good weather, meaning it is not some plus 20 or plus 30. It was 0 and 2 degrees kind of it, but we had very less snowfall on that particular day, and there was a lot of wind just earlier to that, so the snow had been wiped out. So that is why it looks like this. At nights, during the polar nights or the auroral nights, you have such beautiful auroras spanning all across the station zone. So if you go out, you can see such activities. And during winters or during when you have bad weather or blizzards that happen, the station just looks like this. So that station that I showed you empty, it's actually covered in snow. Again, this was not during the extreme winter time. This was just during a blizzard, and we had a high blizzard situation, and the snow was covered. But during winters, we also have snow, accumulating on top. So we have to have dozers and bulldozers which come and clean it off. So yeah, so that was a brief journey about Antarctica and how it is for scientists to go to Antarctica and do science in Antarctica, and a bit about Indian Antarctic expeditions and my experiences. As I said before, I mean, if somebody asks me what is the most interesting thing that you have done or something like that, I always keep telling this. I mean, if you can't go to space, the second best thing that you can do is to go to Antarctica. And I was quite fortunate to actually get a chance, back to back 3 expeditions to actually be a part of the expedition and explore it. And very recently, the last December, January, I did another interesting expedition of exploring the Southern Ocean. I mean, we were close to Antarctic coast, but we never landed on it. It was a 2-month expedition just on the water, and we were just exploring the Southern Ocean and the craziness all across it. So that's an entire altogether a different presentation for it. So thanks a lot. So if you have any questions, let me maximize the window. So if there are any questions around, I did see Professor Ashok Kumar Gwal. I'm happy to hear your lecture in detail. So I was there as a scientific. Oh, wonderful. So expedition 97, 98. Okay. Thank you, Professor Ashok Kumar. It's wonderful to see. And I'm damn sure you would have faced much more crazier time than what it is today, because with the advancement of technology and things, Antarctica is not so hostile. Then I'm damn sure what you would have faced through. Today is a very thanks a lot, Javed and everyone. Ashok Amrasta sir, for the first long time series of. Thanks for the information also. Ashok Amrasta sir says that for a long time series of solar helioseismology was done. See, Antarctica also presents a very interesting place to do solar observations, because you have unprecedented continuous observations which you can do. I mean, especially if I can show you the last photograph, this particular photograph, what do you say? Is it sunrise or sunset? Actually, it is not. So what happens during summer, you have the sun actually coming and just grazing the horizon and then rising back. So even at 3 o'clock, 4 o'clock at night, you go out, you open the window, the sun is there, it's bright, it's extremely bright. So in the station, we actually artificially had to lower our blinds and turn off the lights. Not because of any other reason, but only to keep our mental and psychological balance in check. Because that is one way to trick your body to tell that it has become dark, and you can do the night activity, whatever it is. Because then people who go for the first few days, it's difficult for them to get adjusted in Antarctica, because your mind gets confused. You don't know whether it's day or night. You don't know when you have to eat. You don't know when you have to sleep. So there's a lot of imbalances, and then starts creating problems health-wise. But if not, so to avoid all this, what we do is we end up blinding the station and turning off the lights, turning on the lights during the Indian time. Then what we have. So does geomagnetism affect the telecommunication of other electric instruments in Antarctica? Whenever you have any high bursts of geomagnetic activity or solar storms, it does affect instruments up in the space, but I'm not so much aware. Probably I can, Ankita, right? I can divert this question probably to a geomagnetism scientist, or if there's anyone who's here, probably it should affect per se. But then, those instruments in Antarctica are meant to study them. So I think we should be able to have the thing. Probably I should even inquire about this, and maybe you can just email me, and we can take the discussion forward from there. Thank you, sir, for this thing, Ruslan. Okay. Collapse at the surface. Why do ozone molecules collapse at the surface of the Earth? Okay. I'm not sure about that, but I can tell you about what happens up in the atmosphere, because I'm not an atmospheric scientist. Probably you can divert that question to an atmospheric scientist. But what happens up in the upper surface is that you have the solar radiations, dissociating one of the chlorine atoms which is attached to a CFC molecule. Let me probably take it back to that slide, and then I can just show you there. Yeah. So you have the solar radiation actually dissociating a chlorine atom from the CFC molecule, and the chlorine, when it combines with O3, that is the ozone, it actually forms a chlorine monoxide and an oxygen molecule, the regular O2 molecule. This chlorine monoxide, when combines with another oxygen, the bonds break up, and you have another O2 molecule formed, and setting this chlorine free. So this chlorine then goes and again does the same thing and goes and destroy another ozone molecule. And it is said that one chlorine atom can destroy almost 100,000 O3 molecules. They don't die so fast, or they don't react so fast with anything else. So that is why the CFCs were banned, and that is why we have this. But at the surface, I'm not sure about it. Then what do we have? I was a bit late. Yeah, thanks a lot, Osan. Please tell me. Well, Suni, I don't know where you're from. So, so if you're from India and you're into active research, you can log on and check to the National Center for Antarctic and Ocean Research website. And they do call out for proposals during I think March and April, and and then they'll call you for defending the proposal in front of the National Committee somewhere in the month of June. And post the selection, then you end up doing your medicals and your training exercises, and then you can go to Antarctica. So watch out for National Center for Antarctic and Ocean Research website when they call out for proposals. So this year's proposals were almost done, and so you'll have to probably apply for the next year's. At present, any country uses its nuclear test? No, not at all. The Antarctica Treaty tells you that it is not possible for having to do any kind of nuclear or any kind of military presence in Antarctica. Tell me about the polar clouds, such as mother of poles, how it has happened. Okay, any other, okay, so on that molecules. Okay, Modi, thanks a lot. I'm from India, MTech RSGS from ISRO. So ISRO has a, Suni again, ISRO has a constant participation in the form of SAC, Space Application Center keeps coming there to do research. And remote sensing, I'm not sure because, yeah, but of course you can go there and do validation of your remote sensing, ground truthing of your remote sensing data. So there are people who have participated. Again, NRSC has an active participation, that is National Remote Sensing Center, which is in Hyderabad. So they keep coming to Antarctica. So probably you can check out with your ISRO colleagues from Antarctica and participate through them. And someone had a question about polar thing. Okay, so how does auroras happen? Okay, so we have the high energy particles coming out from the sun during any solar flare or storms, and if Earth is in the path. Now, Earth, again, it's just not a sphere, it also has a magnetosphere. So you have the North Pole, South Pole, and the magnetic lines of forces which go all across the globe. So when this particular stream of jet of high energy particles come and hit the magnetosphere, the magnetosphere actually diverts all these particles towards the poles. It's just like if you see a bar magnet and you see the lines of forces, you'll just understand, and then there are these polar gaps which are there. So these high energy particles come and enter the polar region. So you have it forming towards the Arctic region when you have the auroral borealis that was formed, and in the Antarctic region, auroral australis. So when these high energy particles come and interact with the atmosphere, depending on the ionization, depending on which layer of atmosphere it is happening, whether it's interacting with oxygen or nitrogen molecules, you start getting the colors. So I hope I explained that in brief to you. Is anyone can join the Antarctic training program, or is it specially for scientists? Well, unfortunately, currently, Indian Antarctic program restricts it to only scientists and a few other logistics people. But if you're into science, there is students participation program also. So probably you can even check that out if you're a student. But if you're a researcher, then maybe through your institute you can apply for it. But having said that, Australian Antarctic Division has a art fellowship. So if you're into art or into anything else apart from active science, then probably you can even think of exploring that particular option. There is National Science Foundation, which sends people from US. There is British Antarctic Survey, which people from British people, they have their stations out there. And there are many other countries also. So since it's an international collaboration and Antarctica stations are not restricted to only one country, you can try and explore the options from other countries as well. So in India, currently it is only open and restricted to science. And I was very fortunate because I was documenting science and the station construction activity. So I got a chance. But you'll have to put up a science proposal to go to Antarctica. And yes, happy Teachers Day to everyone. And I see a lot of my teachers also here. Okay. Yeah, thank you. And write to me on my email address, which is there. And probably we can discuss this a bit later if you're interested. Apart from ISRO and NCO also. Okay, so if we have all the questions up, then probably, yeah, I mean, there is again tourism also which exists in Antarctica. There are expeditions that people take from Chile to one of the peninsular islands, but it's crazy expensive. And also it is not proper Antarctica. They take you on a ship. They take you to one of the islands, and then you go there and you come back to the ship, and then they get you back. So it's just a small 14 days, 15 days expedition, and you have to pay a lot. And but you don't get the feel of what it is to be in Antarctica. To be in Antarctica, you have to be in one of the research stations and be there at least minimum of 2 to 3 months. And there are winter teams which stay even for 14 months in Antarctica, and it's really crazy. I mean, out there. So Javed asks, so what is the difference between weather and climate? Okay, I mean, I don't know how to answer that. Probably, I don't know if this is what you meant. I mean, weather is, again, I mean, you can take it as a local phenomena happening around you. And climate is a general overall phenomena. I mean, when we talk about climate change, we have stopped using the term called as global warming, because it is noticed over the last several decades that it's just not, it's warming in all places. There are some places which are cooling also. So that's why the term nowadays people use it is as climate change. So that is climate that is changing. So probably when you talk about climate, you're talking about a global phenomena. Whether, I'm not sure. I mean, if that satisfies your answer, but both of them are quite similar. I mean, you can talk about weather or climate. So when somebody asks what's the weather there, people can also ask what's the climate like there. So I hope that works. Okay, local short. Okay, thank you. I mean, local short term is weather, and if you take a long term phenomena, yeah, it's climate. I mean, you, like for instance, Maitri Station. What is the weather out there? It's a local term phenomena. I mean, but if you see climate, you will want to analyze it for entire year. Is it short term? Okay, climate is long term. Okay, cool. So yeah, so yeah, I mean, if anybody wants to note down my email address, this is me, and there is a small video also on the insightec.com website that gives you a small glimpse about the Antarctic expedition, and you'll get an idea. Unfortunately, I can't share the video. I could not embed the video onto this, but there is some YouTube way of doing it. But then again, that video has a different video altogether. But anyway, so it was wonderful to be part of this presentation and listen from you all and share my experiences. I hope I could give you all some information about Antarctica and my experiences, and I'm looking forward to actually see you all someday going there and doing some active science and contributing to the society in general. So thanks a lot for being a part, and good day to you, and happy Teachers Day to everyone once again. Yeah, thank you.